Thanks for coming out to the Vegas Programmers Users Group. I appreciate everybody coming out. We have a very special guest this month. Joe Mayo here has volunteered. I kind of voluntold him through LinkedIn, not expecting a response, and he happily replied. And after some emails landing in spam and other things, we eventually got this thing coordinated. So thank you very much for coming out. I'm very excited because we're going to be talking about .NET and unit testing. If you don't know what unit testing is, it's basically a universal best practice for software developers to basically test their code, right? Did what I write actually does what it needs to do? Joe here will be providing an overview of what unit testing is. He's going to describe the ecosystem through the perspective of a C# developer. In addition of watching the construction of a unit test, you also learn how to run test runners, do code coverage, and other cool things, I'm sure. Joe Mayo here is an author and independent software consultant. He's been specializing in .NET technologies for, I'm sure, decade or whatever, I can imagine. And what's even cooler is he's written awesome books like C# Cookbook, Modern Recipes for Professional Developers, published through O'Reilly and other things like that. So he's also dabbled with things like AI and stuff like that. So I'm super excited to hear this awesome .NET talk. So I guess without further ado, yeah, if you want to clip that on your screen there, that'll probably be perfect for audio.
How's that?
Yeah.
Okay, great. Right, and so thanks for mentioning my book. I brought a few to give away today.
Hey.
So yeah, I'm going to talk about unit testing with .NET, and of course I've been a .NET developer for a while, and I'll be talking about it through the perspective of C#. But what I really want to accomplish here is to be able to talk about unit testing, how important it is to us as developers and software engineers. So how many people are unit testing? There? Okay. So if you're not, hopefully I'll give you a little bit of incentive to want to do that and to know what the benefits of it are. So here's what I'm going to talk about. I'm going to talk about what is unit testing. And from there, I'm going to go into different types of unit testing. And I'm going to talk about one type of unit testing called test-driven development. And then I'll talk about unit testing afterwards. I'm going to follow up with some discussion about what is testable code. Because sometimes we'll write code, especially in the C# and .NET world, because it's strongly typed. Sometimes we'll write code, but it isn't testable. So if you're going in afterwards and you're trying to make it write unit tests, then it's going to be kind of hard. So I'm going to explain how to a few concepts about writing testable code. And then we'll look at something called code coverage and everything, and just discuss how that helps us with unit testing, and maybe some pros and cons of that. And I'll follow up with some QA. And I've got a slide at the end showing you where to find the code and the presentation slides. And I love the interaction that was going on in here last session and everything. That's great and everything. So if anybody's got questions or just wants to comment on anything, you know what, just go for it. Let's just mix it up and have a great time. So what is unit testing? It's taking a piece of code, which is the system under test, and you're writing code to test that code to verify that it does what you say it needs to do. So basically, that's what I'm going to show you, how to write a unit test that does that in .NET. What isn't a unit test? Well, there's a lot of things in your code that, and how a lot of different types of testing that we use that are not necessarily unit tests. But when you start testing like multiple units or multiple pieces of code, like a class in C#, then you end up doing something that's called an integration test to see how these units integrate together, which is not necessarily as effective as a unit test for automated testing, because you see, if you're testing another piece of code that talks to a database or the file system or does an API call, then all of a sudden you can't automate that test like if you're doing CI/CD, continuous integration, continuous deployment. What you want to be able to do is take these unit tests and automate that so that every time somebody checks in code into your source control, you want to run those unit tests along with checking those tools into code. And by being able to isolate it to a single unit, this is super important. So let's talk about types of unit testing. And there's a lot of people out there with a lot of opinions about how unit testing should be done. And one of them is test-first development, test-driven development. And you may hear it used by other names. But essentially what this is, it's like you actually write the test before you actually write any code. You make the test fail because there's no code to support it. And then you go in and then you write the code and then you retest and it passed. It's like red-green testing. Make it fail, fix it, and then write it. Another way to look at this, and some of these people will ask you in interviews, or they've got this saying, they said, how do you know that the code works unless you've tested it first? Just think about that. How do you know unless you tested it first? And that kind of derives from this perspective of a unit test being as a system of design. Because imagine you know what you want to build, and you write a test to say, this is what this code should do, and then you go make it do it. So it's kind of like design before writing your code.
The problem, you said you want to interact it, right?
Sure.
The problem with TDD is that unless you're sure what functions you're going to write, you end up throwing away a lot of stuff because you really don't know necessarily. Things change as you're writing the actual functions, and it makes me nervous to try to write tests before I actually have a function. I understand the point of TDD.
Yeah.
And I think it's I'm a firm proponent of unit tests completely, of course, but I would write them in conjunction with the code document.
Yeah. Yeah, so the perspective here was that sometimes you don't know what you're going to write. You just get in there and you start working on it and everything. And if you write these tests before you get in there and do it, then all of a sudden you've wasted your time writing a bunch of tests for code that will never see the light of day. And that's really a good point. And that's why we have this other type of testing. It's like testing after you write your code. This is what a lot of people do. And so this perspective is real in this way because you see, especially when you're experimenting and you don't know what you want to write yet, test-first development can be hard. And it's also hard to think that way because you have to change how you go about writing code. Most of us, we go in and we write code, and then maybe we get lucky if we test. But I'm kind of like an advocate of whether you do test first or whether you do test after, the unit testing is good and everything. And as we go through here, I'm going to show you a few reasons why unit testing is good. So the test-driven development comes from the perspective of kind of like designing the code first, and your design is in the code. But let me show you test first. And I'm gonna go ahead and do a demo here. And this context is from building a system that reads files from the file system and returns an object that takes that file and turns it into text. And you see that logo up on the top right of all my slides, Generalem? That's a new open source project that I started. Really, it's an open source startup. And I'm building it so that businesses can use their own data using AI. And one of the things it does, it goes out on a file system and it reads all these files and pulls out the text so it can use that as data. And this is kind of like derived from something I've actually done. But look at the requirements there. We have the product manager has gone out, talked to the customer, and figured out what we need to do. So we've thought about things ahead of time. So you've got a really super good requirement here. Build a document type creation factory so that we can go to that factory and say, create this thing that I can get text out of. And we say if the file name ends with doc or docx, then it's a Microsoft Word file. If it's a PDF, then it's a PDF file. And if we don't know, if it's not one of those two, then we don't know what it is, and we'll return an unknown document. And also we have a requirement for the file name that we give to this method to actually have a file name in there. So if it's null, then we'll throw an error.
Is the point to, why do you care what the font the name is? Are you trying to pull out the metadata and that kind of thing? You just want the actual text?
Yeah. So what's the point of the function?
The point of the function is to return the data in the file, but are you going to just output all the metadata in a text file?
Yeah, we're gonna take that text, and in modern AI systems like large language models, what we want to do is we want to take that text and vectorize it so that it goes into a vector database. And then when somebody does a query to the AI, the large language model, we take that query and vectorize it. And because they're vectorized, we can use closeness models that we can go into the database and say, well, the question is close to this text, pull that out, and then send that up to the large language model. Yeah.
So the only data of interest in each file type is plain text, right?
Yeah, so the question is the only data of interest in each file type is the text, right? Right, so let's go look at that. Okay, so I have over here this project, the unit testing with .NET. And notice that I have a document factory there. And I've got a PDF, Word, and Unknown. So let's go look at what each one of those are. Document factory is what I'm going to implement. But I've got a Word file, and in C# we work with objects. They're called classes. And there's my Word document, and it implements this thing called an interface. And in C# we have a formal notion of what an interface is. If I have something that implements this document type right here, right there, then I know whatever I get back has a get text. So I've got a document type, I've got a file name, and I say get text out of that. So now I can operate on any of these the same way. Same as unknown, same as PDF right there. So I've got this document factory. Yep. Come on in. So I've got this document factory here, and I'm going to re-implement that right in front of you. And I've got this project here, and it's called Unit Testing with .NET Tests. So that test project references the other project. And I've got a file here called Document Factory Tests. And I'm going to comment that out because I'm going to implement this. Okay. Okay, my mouse skills need to get better. Okay, so let's say I'm going to write this test right here, and I'm going to put it in. I'm going to uncomment these, because in C# this using says I'm using a namespace over here, and a namespace says, okay, I've got these classes that go in this namespace, so I can use those without fully qualifying the entire name. And now I'm going to write a brand new test, brand new class, and it's got to be public. Okay, and what I want to do is my system under test is going to be this document factory. But I'm going to create my first test. And in C# there's these things called attributes. And I'm going to use this attribute called fact. See the syntax, it's got these square brackets around it? And I'll tell you more about that in a second. But here's my first test. I'm going to say create. There's a create method, a function. And I'm going to say with Word doc returns Word document type. So this is a method itself. So here's what I'm doing. That fact is an attribute, so it's metadata inside of the file. They're called assemblies. When .NET compiles, it creates this thing called an assembly, and the attribute is metadata inside of there. C# also has this thing called reflection. So the unit testing tool that I'm going to use for this uses reflection to read the metadata out of the assembly to find out what the unit tests are. And then it finds unit tests, it runs that method. Okay, so the first thing I'm going to do is I'm working with the document factory, right? And so that doesn't exist. You can see my red squiggly. So if I go up here, I'm going to create a new document factory. And I'm going to create a public class. There. Okay, now since that's there, if I go back over my test, you see how that lit up now? So that was my first failure. I typed document factory, it wasn't there, I put it there. And now in C#, I created an instance of that class. Once I have an instance, here's what I can do. I say iDocument type. Remember I was telling you these interfaces? I can take any of these classes that implement that interface and just treat it like the interface. So here's going to be my second error. My Word doc dot docx. And so I get an error here. Document factory doesn't have a create, so let me put that in there. And I'll make it public again. It's got to be public because I've got two assemblies. I've got the test that's trying to read the main assembly there, so it's got to be public so it can see it. And I'm going to return a iDocument factory, iDocument type, create, string, file name. Okay, so I've got that. And now that compiles. Now I'm going to do the third part of my test. I'll do assert is assignable from a Word document, doc type. Okay, so now look at the structure of my test. This part up here is called arrange. We've got this triplet of how we do unit testing. It's called arrange, act, assert. Arrange means you're setting up the conditions for the test. Acts, you call the method that you want to operate on. And then assert is you're validating your assumption about that test. And in each unit test, you want to test one thing only. Because what happens is later on in maintenance, if that method changes, the logic changes, you don't want to be messing around with changing one test that's testing more things than one. So it makes it more maintainable. Also, look at the name of this test. How I said create with a Word doc returns a Word document type. So now, with that unit test in there, if you want to go in, you want to understand what a piece of code means or what it does, you can actually go read the unit test. You can read these headings of the method names to kind of understand what that code is supposed to do. So it's kind of, in another perspective, it's a way to document the code. But let me run that. I'm gonna right click, and there's run test right here, Control RT. And what it'll do is it'll go out there and it'll build that code. So it's building the project that it depends on as well as this. And I have an error that says not all code paths return a value. So let me go fix that. It's my document factory. I'll return null right now because I'm writing a failing test, right? Test-driven development. So let me run that again. And here's my test explorer. And you can see that it's red. And then see, it says expected it to be that type, but it was null. Okay, so now I'm going to make that test succeed. And here I'll say if, before I do that, I'm going to say string extension equals path get extension file name. And this is Visual Studio. It has this nice code completion. I just tabbed through that. I say if extension equals .docx, then return word, new word. There. Now let me run that test again. Okay, now I'll call code paths return a value. So let's fix that. Remember when something's not recognized in my requirements, so I'll return a new unknown. There. And now I'll run that test again. Oh, wait. Okay, and this time, yeah, it passed. And so here, I'm going to shorten this up a little bit because you don't want to see me going through all of that. So here is a complete implementation of this, but let me show you one thing. And this is important. See this if, the extension is that or that, and that's a word, and then a PDF, and then return this. And now I'll go over to my tests. And I'll comment that out. And all of these tests right here that I had, here you can see how I wrote these tests as how did I do that? Okay. Okay, you can see I wrote a test for each one of those cases. So I have my requirements. I went in and I wrote the test. So when I run all of these tests, I'm going to go hit Control-RT. Doing this process of make it fail, do the code, and then verify that the changes that I made work. And you can see that all my tests are passing. Now, let me show you one of the benefits of unit testing. Because you can see my logic I had there, if, else if, and all this other stuff. Well, when you go back into your code and you have to do maintenance, and when you start changing things, stuff can break. And one of the benefits of having unit tests is you get regression tests. So now I'm going to use this really super cool statement that simplifies how I'm going to manage that. In C#, that's called a switch expression. And we're using something called pattern matching. And so you can write some really succinct and easy to read code by doing that. So now I changed that. Let's make sure that the changes that I made in maintenance work. So I'm going to Control-RT here, run that again. Oh. Let me stop this a second. Okay, where's my tests? Okay, so that built. I go over to Test Explorer. Oh, okay, that was just that one test. Let me do them all. Okay, so I changed that code, and my tests still run. So here's what I got out of that. First of all, I'm going to know whether my stuff broke or not. It's also going to tell me whether I implemented this test correctly. But here's where it's really powerful when you combine this with CI/CD. Every time somebody checks in code, you can set your pipeline to run these tests too. And then if they've broken something without running the test, because of course, if you're working on this code base and you're changing code, you need to run the test before you submit your code as a PR. But a lot of really experienced developers even forget to do this. And then they try to check in their code, and then they've checked in errors. But if you have this automated with CI/CD, and it's going there, and every time you check in, it runs those tests, it's going to prevent the check-in. You don't break the build for your other teammates. And over time, you literally get hundreds of tests. Let me show you. Anyway, I've got this other open source project that's called link to Twitter. I've got about 600 tests in it and everything. So these gather up over time. But you see, because you're doing unit testing, you're not testing multiple modules and everything. These tests are really super quick. And so when you go and you do your check-in for your CI/CD, the tests run really fast. You're not going to be sitting there a half hour. I mean, Visual Studio is really fast, and if you've got a good server, you'll get some really fast results. So anyway, that was test first.
Joe, first, thank you for live coding for us. Always fun and a risk, and appreciate you being brave in doing that. And the second is, I was trying to think of a funny joke about test-driven development, and then I realized that, I think most of us, well, my comment was going to be, we're, for us PHP and JavaScript developers out here, I didn't see any console.logs or out statements or anything like that, which I think is how a lot of developers start off writing unit tests without knowing it, but it's tightly coupled, right? Like we're sticking debug statements in our code at every code path with like a statement like, am I here? Or hello world, or why the hell isn't this working type of thing, right? And this is the absolutely, where we all need to get to as developers is to uncouple our reasoning about whether something is working and turn it into a program on its own, which is like the test runner plus unit tests. So thank you for showing that.
Okay, great. I'll summarize and everything. So, yeah, I'm happy to do live coding and everything. And it's fun, and I'm not afraid to make mistakes and everything. And Jimmy just paraphrased how doing this test-driven development is really useful for people who are learning to code, and a great way to decouple their code from dependencies that they put in. And that's actually an excellent segue into like the next section that I want to talk about. And that is, actually I've got this other thing about automating development. So how many people have used like AI coding tools? Oh wow, a lot and everything. So you probably already know that some of the pros and cons, because sometimes they can reduce the amount of time that you can code, as well as in unit testing they can cover cases that you might not have thought right away and everything. So they're really convenient for unit testing. Cons, and the con is not unique to code at all or unit testing. It's all about using modern AI because it hallucinates. It gives you stuff that doesn't really exist. So whenever you're using these tools, always have reviews and make sure that the code is doing what you want.
Yeah, so I'm glad you mentioned the AI thing. I wanted to mention that I've used two different workflows actually with AI. One is you write tests and tell it to fill in the production code, and the other is where you go the other way. You give it an untested function and ask it to write the tests. Right? I don't know if you've used that at all in your workflows, but.
Oh, okay. Say this first part again so I can.
So if I write a unit test and I ask the AI to fill it in.
Oh, I see.
Right. What I've found is that for unit tests specifically, it writes bad production code just because it's specifically linked to only the cases the unit test you gave it is.
Mm-hmm.
And you can create a bad unit test in that case where it is linked to the implementation as opposed to linked to the behavior.
Mm-hmm.
Right? The reverse doesn't seem to be true. Like it seems like when you give it a production function, it extracts all the edge cases and runs separate tests for them. But if you go the other way, it won't work as well.
Oh, okay.
You know what I'm saying?
So let me paraphrase what was said and everything. There are two cases with your unit testing with AI tools. And one is you give the unit test and say, hey, write code that does this and everything. And sometimes you get incomplete code because if your tests are incomplete, your code is going to be incomplete too. The other way around is like, okay, you said that seems to work better for you. Okay.
Yeah, and it wasn't that the tests are incomplete, it's that the code that you get is tightly coupled to the test. So instead of testing a behavior, you're actually testing the code that you wrote.
Oh, okay. So,
You know what I'm saying?
yeah, so the
Testing
code
model,
is
you're testing-
is tightly coupled to the test.
Right, yeah.
Okay, so I'm going to show you a demo if you haven't seen this yet. So I've got over in code, VS Code, I've got this method highlighted right here, and you can see ask async. This is actually taking a query, and it's going out and sending the query to the LLM, the large language model, and getting a response back. And I want to write unit tests for this. And I'm using this AI coding tool. It's called SourceGraph Coding. And they don't have support for Visual Studio. But what I've done is, it's free. You can use it for free if you want. So I use it in VS Code, and I generate my unit tests and copy that and put it in Visual Studio. So if I right-clicked on this, I've got a Cody item in my menu right there. Oh crap, it's saying sign in right now. But anyway, I can't demo that right now because my internet is not connected or something like that. And let me try to reopen that, because this is a really cool demo if you've never seen it before. And I'll go open the GeneralM. Let's see if it reconnects to Cody, because it requires an internet connection to go talk to the AI. So right click, fingers crossed, yes, yes, yes. I said generate unit tests. And it pops up a new window, and watch this. And so I'm using this test framework. It's called XUnit. And I guess it went out there and recognized that I'm using XUnit, and it's building compatible tests for me. And then it explains the tests, and I can just go copy right here and boom, and pull that over into my code. Well, let's peek at this a little bit. Remember I was talking about hallucinations? Let me see. Let me see if I can find something in here. Interesting. I can't find anything, but every once in a while it sticks a type in there. I've seen it do this. I'm using mocking frameworks, which means that if I have a dependency that I want to inject into my class, I can mock that dependency so that I isolate my unit of code and everything. And sometimes it'll give me a mock class that doesn't exist. So that means I kind of like got to either go out and create that myself or something like that. But anyway, that's even if it isn't perfect in generating my unit tests, it takes care of all these cases that I might not have covered myself, and helps me go quicker. And I know I have to read the code anyway, so it doesn't bother me. Any questions about that? Yeah.
Yeah, I think now with AI, there's no reason why you shouldn't be doing unit tests. And another reason also for unit testing that I found helpful is when you're writing unit tests and it becomes really hard to test the code, it could be also because your function is very long. And so it kind of forces you to write smaller functions so you can test them easier.
Oh, okay. Yeah, I love that perspective. Let me repeat it. So yeah, you're an advocate of unit tests and everything, but also if you're writing a function, you got this long function, you've got to write all these unit tests for it. That should put a reminder in your brain to say, well, maybe I've got that function doing too much stuff. Maybe I need to modularize that and break it up some. And so you end up writing better code out of that.
Here's what I would say on why write unit tests, and I'm a big, like I said, I'm a big believer in writing unit tests. These are all good reasons. The fundamental question, I think, in my opinion, is if you've got some code that's running in your organization or whatever, and you don't have unit tests, and someone asks you, is this code working? If that code has changed even slightly since the last time you ran manual tests, the answer has to be, I don't know, unless you have unit tests. If you have unit tests and someone asks you, is this code working? You can say yes, because all the tests passed. The last time I ran them, even with the changes that were made, the tests still passed. So to me, that's the fundamental, that gets down to the fundamental point of unit tests, is so you can answer that question all 100% of the time.
And with AI, there's really no reason why you shouldn't.
I haven't tried AI for unit tests yet, but
It makes it way easier.
I imagine it probably does, yeah, people have talked about it.
Developers always saw it as a tedious task, right?
Right.
Tests, and always, that's why those things got left till the end, and then all of a sudden completely forgotten about, not even written at all. But I'm curious, what sort of AI tools do you use? Because I'm familiar with Copilot, and that seems pretty good, but this Cody one is new to me. So have you used other ones, and is Cody kind of your go-to now, or is just Cody your first one that you've worked with and it's worked well?
No, I started off with Copilot. I got it while it was in beta, but unfortunately, I didn't get the chat part of it, so it was kind of like crippled for me. But Cody has the chat part, so I've been using Cody lately, and then I've had a couple people on X because I'm kind of like posting about it. I've had a couple people on X give me a couple other tools that I'll need to be looking at, and so I'm going to do a survey of all the tools to find out, you know, what the capabilities are out there, and I'm sure there's going to be some leapfrog going on in there, but it's very exciting.
Yeah, I think that could be a complete demo in itself.
Yeah,
Unit
we
te-
did
AI
really talk
unit testing
about
would be a
Copilot
great
in
talk.
the past, but there seem to be a lot of new ones now.
Yeah.
Yeah, because I use ChatGPT, and I don't know, I just copy and use my code there.
Yeah.
And then also, it helps me with documentation. It kind of I ask it to, can you write documentation for this function? And it writes it really nice. I just edit it, take out things that I don't need or modify. And it helps me also document my code way easier instead of me having to think about what it's actually doing.
Okay, great. Let me summarize a couple of the great things I've heard. I got one gentleman said that the fundamental reason of unit testing is so that I can answer the question of, does this code work, and everything. And you said, you know what, unit testing is going to make things easier. I especially want to focus on what you said about unit testing being perceived as tedium and everything. I look at unit testing as a part of the code that you write. And like, you shouldn't be having to ask your manager for permission to do it, because your manager wants high quality code, and this is one of the techniques you can use to improve the quality.
Yeah, so two things. My first one's a comment on that. I generally tell people who argue with me about unit tests that it's sort of like telling your surgeon you don't want him to wash his hands. Like, this is a professional, this is a thing that professional developers do.
Yeah.
It's part of the process, and, you know, we don't just skip it because we feel like it.
Yeah.
Now, obviously, you have to have some kind of political clout or whatever to get away with it. But, the other thing I wanted to ask you, actually, my experience with TDD in general has been that if you really understand the problem that you're working on, then you can kind of write the tests first. When you have a situation where you don't really understand what it is that you're building yet, it's been my experience that I generally have to write the solution first, backfill the tests, throw the whole thing away, and then write it again to fill the tests. Has that been your experience too?
Yeah, mostly, and everything. And so this is let me paraphrase. This is another one of those examples where you don't know what you're writing, and so how can you write the test when you don't know what you're going to write in the first place? But what you said on that last part is like you write your code and then you write the test for it, and then you go throw away your code and rewrite the test and everything.
Yeah, throw away the original code, because usually it's a mess. So rather than even trying to refactor it,
I
now
see.
you know what the problem is you're trying to solve, you can approach it from a design perspective that's a little better.
Yeah, I was going back and doing. Okay, yeah. So I go back and I do the refactoring, but I don't throw code away.
Different people work in different ways.
Yeah.
I'm a throwaway person I'd rather just put my hands in there, start moving around stuff, and
Yeah.
but not everybody's like that.
And to tell you the truth, when I started Generalum and everything, I didn't know what I wanted to write. I just knew I just wanted to do something, and I just started coding. And in some cases, I knew what tests I want to write. But now that I have my patterns and it's come together, okay, now I can go more into TDD because, like, say for instance, I got the Word and I got the PDF files and everything. Well, what if I want to do all kinds of different type of file types like PowerPoint and Markdown and all this other stuff? Now that I know what to expect, I can do the TDD on it.
Right, but now you know the problem space.
Yeah.
Hot question. Referencing the Gang of Four refactoring book. My question is, can you actually refactor if you don't have unit tests written beforehand?
Okay, can you actually refactor if you don't have unit tests? Very carefully. but really,
I think the hot take is the Gang of Four says no, right? Like refactoring starts with testing the code and then changing the code according to various patterns and then rerunning the test to make sure it still does the same thing that you did before.
yeah, and that's another use case of why unit tests are really great, because how do you have confidence refactoring that code that you're not going to break something else? Well, it's the unit tests that keep you out of trouble. Okay, how much time do I have?
25 minutes.
Oh, I still have 25 minutes? Awesome, I can finish this. Okay, so let's talk about writing testable code. What languages are other people using around here? JavaScript? A few JavaScript, some Python? PHP? Okay. Huh? Fortran. Oh my God.
Yeah, COBOL.
Okay. There's some idioms about C# that make its experience with building unit tests different. But you can think it's probably the same with other object-oriented languages like C++ or Java or anything that you like build an interface with. But writing testable code is a little bit different because C# is very strongly typed. You've got languages like Python and JavaScript that are dynamically typed. And so you can use mocking frameworks, and the testing may be a whole lot easier because you can pretty much mock everything. I did some unit testing in JavaScript recently pretty heavily, and it was like really easy to unit test. But with C#, because everything's strongly typed, things change. But here's a few tips. IOC with your instantiation. So when you start looking at things like, how many people know what design patterns are? Oh, okay, a lot of people. Yeah, it's a way to use the same style of programming and put a name to it so that you can communicate about what that code does. But in design patterns, they have a lot of things called interfaces. And the interfaces is what the code is based on. And you saw that I document type interface that I showed you, that everything's that interface. So now I can build a pattern out of that, like a strategy pattern. So where I say, okay, if I want this, I can use this document and this document, and I can turn it into an iDocument type and use this object-oriented principle of polymorphism to do that. In addition to that, because of the strategy pattern, now I can add all kinds of different document types. And then my code doesn't change, just the factory that says, give me that document type, but the code that operates out of that document type never changes. But with IOC, because I'm using interfaces, here's what the problem is. Because we want a unit test, we want to isolate the system under test. Well, we don't want the system under test instantiating objects, because all of a sudden it turns into an integration test. You're testing more than just that one unit. But IOC gives us the ability to inject the dependencies so that the system under test is not instantiating that. And it also gives you ability to isolate that code. So you're testing only that one piece of code.
.NET Core has dependency injection built in. So
The what?
it has dependency injection built in.
Yeah, it's part of .NET.
Yeah, that's what I meant. Yeah.
Yeah.
.NET Core. I mean, you're talking about C#, right? So,
Yeah.
so that
But of course, there's all kinds of open source and third-party tools that help you with that too. But now we've got some really good
Because
support.
IOC is usually for the more, that's usually when you have a library that doesn't use interfaces, that you need to build a factory to do IOC. Other than that, it's
Right.
usually just built into the,
Right, that's actually my third point.
oh, I'm sorry.
It's like if you get a library, a third-party library from someplace else that doesn't have interfaces, that doesn't support dependency injection, you can use a factory. And then create an interface off the factory and inject the factory into the code.
So I have a question on this under. So does languages like Rust come along and change like your testing landscape, right? Because it's very strongly typed, it has to be compiled beforehand, and if there is like anything that's not matching types, then the code just literally just doesn't work at all, right? So do you really have to write lots of unit tests with like languages that are so constrictive on the developer like portion of like the development before it actually gets into like production? Like how does that like?
Yeah, so you said like Rust is strongly typed and everything. So yeah, you have to write it so that it's testable. Otherwise, you really can't test.
Yeah, no, I think when you're testing, when the code compiles, that it compiles, you're not testing that it functions correctly. Unit tests test your logic, and that your program does what it's supposed to do. Right, it can compile and still do the wrong thing.
Okay.
One more quick, well said. More quickly, you're pushing interfaces, and that's a good thing. But technically, interfaces are supposed to be behaviors. They're usually used wrong. So your interface should probably be called has text from a really purist standpoint. But if you're going to talk about interfaces, you should really talk about the right usage for interfaces.
Oh, okay, yeah. So yeah, I'll show you more examples of interfaces that I've written. So let's go look at that.
Sorry, that's more of an aside, so I don't really want to derail your demo.
Yeah, I'm actually planning on showing what I just talked about. So those, because it's like conceptual. It's hard to wrap around your head until I actually show you what I'm talking about. So you had asked whether .NET had like built-in IOC, and it does. I've got this GeneraLM console right here. It's a runner for this thing, and let me see. Okay, so this host is a .NET application, and what I'm doing is I'm configuring this application. Part of the configuration, if we go down here, is this method called configure services. And I've got this interface called service collection. And look at what I'm doing here. Add transient. I'm saying for this interface, give me an instance of that class. So now this is an IOC container. And I go to the IOC container and I say, oh, okay, if you see this interface, give me this class, and that's what I'm going to inject into a class. And I'm setting all this up. So let me show you an example of that. For example, if I go into this LLM, this calls a large language model. And I'm using Azure OpenAI. If I open this class, you saw me use the new statement, right? When I say new, I'm creating a new instance of that class. And when I say new, I can give it parameters. So look, I've got this Azure AI Open LLM. Look, it's using these this is actually this factory. This is a factory class that gives me back an object. So we were talking about factories earlier. And so I used the factory right there, and I said, give me, create this OpenAI client, and now I've got an instance of that. And see this, that's a field inside of this class. So now I've got this OpenAI client that I can use to actually call into. Now, if down in this Ask Async, if I were to start creating new objects down in there, I wouldn't be able to unit test it, because all of a sudden I'm not only testing this, but the test will call down into this other object. And once you start calling into another object, another module or piece of code, then you've got an integration test, and you're not able to isolate the code. So that's the benefit of that. You can see me using interfaces all over the place. But this Ask Async, let's go look at the test for that. Visual Studio's got this really cool thing where I can go look at all the references. Okay, come on, keypad. There we go. I got a test right there. Look what I'm doing. I'm using this mocking library. It's called mock. Let me go up here. I've got it in a global using somewhere. But anyway, I'm creating an instance of this mock for the iConfiguration interface, and I'm instantiating it. So this is allowing me to inject these instances. They're mock instances. I can inject those into this. Is a bit complex, but look what I'm doing here. This configuration mock, and this is the factory mock. Remember the OpenAI LLM that I just told you about, where it had these interfaces that were coming into it? It's really those interfaces were instantiated by the container, and when the application calls an object of Azure OpenAI LLM, it instantiates one of these and injects it into the class. So now I can write a test that creates an instance of this, and the dependencies are injected via these mocks. And these mocks don't have any functionality. They don't do anything. So I can actually make a call to it, and it'll return, but not give me anything back. But look what I can do with these mocks. I can set up my test. I could take that configuration and say that whenever I call into that configuration for that key, I'm going to get this value back. So now when I run this test, and I've got this method that calls that configuration to get that back, inside of the code, I'm going to have a value there so it can continue with the test. And here you can see me, the arrange act assert. I'm arranging this because these are the type of things that it expects to get. And then I'm calling ask with that request. I'm getting a result, and I can test it. So IOC means inversion of control. That's dependency injection, so I can inject my types and make my class testable. A lot of ceremony, I know. If you've done JavaScript and you're mocking with that and everything, it's probably pretty doggone simple. But this, once you're using strongly typed languages and everything, you just get used to writing the code. So this is not really strange to you, but this is how you go about doing it with C# and other strongly typed applications. Oh, and by the way, this factory right here, I showed you how that worked. So, questions, observations about that?
I have a .NET question.
Sure.
Because I'm curious. It seems like sometimes I'll create a function, and you have your parameters you pass into the function within your parentheses here. And I believe these ones in the greater than and less than are quote unquote generics, right?
Yeah, those are
And
called generics.
Coming from PHP and perhaps other languages don't support that feature. Can you explain a little bit of the difference there as to why that wasn't as listed as a parameter, I guess, in the actual function versus all of, because the way I look at this, there's almost two sets of parameters I can pass into mock right now, right?
Yeah.
Like the type of what mock could be, but then I'm saying new, and then nothing's being passed into those parentheses right there. In PHP, it would just be like making a new mock class, and I'd be passing in new with what I want it to be, right? So I'm
Yeah.
just curious as to like why, I guess in the sense of like a language construct, what you would determine to put as a generic versus as what you would put as listed as a parameter.
Oh, okay. So yeah. So the question is, please explain generics, because people need to understand what should be a parameter versus what should be a generic and everything. And if you look at this generic right here, it's mock of Azure Search Service. So the generic parameter is a type parameter. In C#, everything's strongly typed. And so if I build a class, that's a new type. It's a new type that does something and has a certain amount of data. And so everything's based on types. So if you use a generic parameter, it's a type parameter. But if you use any type of other parameter, it's either another object, it's an instance of an object, or it's some kind of value. And so those have to be parameters. Before generics, I mean, C#1 came out, they didn't have generics until C#2. And so what we handled with that, the way we handled that was we had, instead of one parameter, we had two. And we would put the first parameter was a type parameter. We would say type of this. And then inside the method, we would check the type and do all kinds of things. But now that we have generics, and this mock says, oh, okay, I have this interface, I'm going to build this fake object that allows me to have the methods in that interface. Is that clear?
Yeah.
Let me see if I can add a little bit to that. The biggest reason I know of for generics is that you can make assumptions about like if you want your class that uses a generic, that has a generic type, to call methods on that object, you have to know that it's a specific type. Right? So, as opposed to doing new, when an object would come in, then you have no idea, it's just a plain old object. But if the class has a type parameter, then you know what it is, and you can use it from that point.
So I thought the point of a generic was that it's generic, right? Like, can you type hint what a generic should be? For example, could I say, I have to have an interface of this
You can.
in order to say what type of generic that needs to be?
You could.
Yeah.
There's constraints on it.
Yeah.
Yeah, you
I'm
can
getting
put
off topic a little
Yeah,
bit
sorry.
for the unit.
We'll talk. We can talk about that later.
Yeah.
Yeah, but it's interesting, you know, to be able to understand the code, to understand what the generics are doing. So really, making code testable, because if you're doing maintenance and you want to do unit tests on an existing code base and everything, what you're going to have to do is, like, you have to take a part of the code that you need to test and say, okay, well, I have to refactor this code, and then you're getting into the danger zone again, like you mentioned, to say, well, I don't have tests, but I'm going to refactor. Well, that's a little bit dangerous. It takes longer. But that's what you have to do. If you've got a code base without any tests and you decide you want to start unit testing, here's what my recommendation usually is. It's like, go into the parts of the code that you think are tricky. And really, if you're keeping track of, if you're doing, in your project management, you're keeping track of bugs, well, your project manager is going to know what parts of the application are particularly buggy. Well, that's a case for a place to start with your unit tests. Because once you start rewriting that code to make it testable, and then write unit tests on it, then you can eliminate an entire section of bugs in your application. And so just grow from there. And then as you're doing reviews, when somebody checks in code, you ask them, here's how I do it. I say, okay, what about unit tests? And everything. And sometimes if you're in a hurry, they don't get in. Other times they do. It just depends on your team and your policies. And any stories about that anybody wants to share? No? Okay. Cool. Okay, so let me get back to here.
Yeah, I guess I have one there. When is it too late or a project too big to actually write some like unit tests? Because I try to push for this in the last company I worked for, and they have lots of production code and all that kind of stuff for like over 40 years. And I don't know how many millions of lines of code they have in the block. And they were like, no, we can't unit test because you probably have to rewrite the code in order to do their unit tests. And refactoring, you're probably going to like break it. We're going to spend a whole lot of time, money, effort, all that kind of stuff in order to do this. So no, we have a manual process. We're going to put it back in the hands of the big brains. So like, I guess like, what do you use to like combat that legacy mindset?
Yeah. Okay. So you've got a large code base, and how do you actually start doing unit testing and everything? And I think the thing to not unit test just because it's too hard is not a good thing. But you can't boil the ocean. I mean nobody's got a budget for that. You got to look at the money that it's going to cost the company for the developers to go in and do that. So it's not productive to even do that. But if you go in and you chip away at it and you say, okay, I've got to write this code and everything, it's like anytime you got a piece of code that you can actually refactor and isolate so that you can write a unit test on it, okay, chip away at it. But don't say I can't unit test at all.
No, I'm saying like that's how do you get the pocketbook holders to sign off on unit tests after 40 years of not doing that? You know what I mean? It could be like, hey, this is the modern thing. This is for professionals. We all do like we want professional work to be like done and everything, and this is like what we're now advocating for.
I don't ask. I don't ask. I see it as part of my work.
But customers are billable.
I hate to cut it short, but we only have a few more minutes. And
Okay.
I see you have a couple more slides.
Fair
So.
Okay, writing testable code. Okay, yeah, great discussions, different perspectives, and I respect everybody's perspective, so I'm getting that. Code coverage, we only got a couple minutes and everything, but let's just talk about code coverage. In Visual Studio, I can go to test, code coverage, boom, and it goes in and it shows me all the parts of the code where my tests are covering. And then it shows me the parts of code where my tests are not covering and everything. So that's a great way to go in and say, okay, maybe I need to go over here and cover those tests a little bit more. It tells you how much coverage you have. So it's a really useful tool, but I've got this question here is, should you have 100%? And it kind of like goes into some of the questions that we've been having here. There's parts of your code that doesn't make sense to unit test. It's like maybe there's a property, maybe there's a field that the code coverage tool is telling you. But what you want to do is you want to make sure that you're getting the critical parts of the code. If you got buggy code somewhere, that's an indication you need to go in and start working unit tests on that code so that you can bring it back up to speed. But 100%, you know what? You're just killing yourself for nothing. It doesn't pay for itself. Okay, so I was going to do a demo, but we're running out of time. This is my slide and everything. So, what are the two different types of, if anybody wants a book, what are the two different types of testing?
TDD.
Yeah, I got three people. There's a gentleman in the back. He had his hand up first. Okay, and yeah.
One of many books that Joe's written, published.
Yeah, I wrote 9 books. I guess 10 if you count an ebook I did for Sync Fusion. Should you have 100% of code coverage in your application?
If you need it.
No, you don't need it.
No, you don't. Sir? Okay, and when you're what's one of the primary benefit of writing unit tests?
Get to sleep well at night.
Get to sleep well at night. Yeah. Okay, that's good.
I already actually have one.
Oh, actually.
I'll take it.
Okay. Yeah, because you answered. Okay.
Answer right there. You can actually
And
answer the question. You know how this
and
works.
what is one question that I haven't asked that really hit home?
Say that again?
Yeah, you guys asked me a question. What question that did I not ask in the last couple of minutes that hit home for you in this presentation?
I want to know what your prompt looks like for writing unit tests, like what extra information you put into your chat prompt.
My chat prompt.
Yeah.
Oh, okay. Okay. Anyway, so you had a lot of good information for me. So there we go. And that concludes my presentation. Get a hold of me, talk about unit testing and everything, and appreciate it.
Thank you very much, Joe. Appreciate volunteering to come speak at the user group. This recording will go up on Tech Alley's website, so if you know a friend that needs to write better tests, send them this video. Shout out to Tech Alley for sponsoring the meetup. Thanks to Ryan for recording. We have two sponsors, JetBrains. We've got a couple of free licenses to give away. Grab my card here when you leave. Email me if you want a free 1-year license. In fact, they came out with an AI tool just a couple weeks ago. And then also corporate co-working. If you need co-working space, give them a shout out and they'll hook you up. It's a really nice space. I've been going there for a little bit. Other than that, I'll be doing a talk about CI/CD in January. I was supposed to do it today, didn't have the time to put the talk together, and then Joe was able to come through. So thank you very much. Yeah, I think that's about it. We'll all head over to the Taverna now. Yeah.